Okay, let's look at the nomenclature for alkanes as an introduction and how we relate the structure of a hydrocarbon or organic compound to its name. So first let's talk a little bit about structures. One way we can draw structures is called line bond structures, which they're Lewis structures. So for example, I could have a line bond structure like this. Sometimes people don't draw the hydrogens on. They'll just do lines. It's this one way of simplifying it, but we'll put our hydrogens because we're used to having them there. So you'll see line bond structures like that, but that's kind of a lot to draw out. So there's another kind of structure called a condensed structure. They take each carbon unit and draw it with the number of hydrogens attached to it afterwards. So this is this first section right here, carbon, and it's 3 hydrogens, and they just always put the hydrogens after the carbon in the way that we read it, even though they may have, the picture kind of be before it. Then the next unit would be this carbon, and it has 2 hydrogens with it, okay? The next one is a carbon with its 2 hydrogens with it, and then the last one we have a carbon with those 3 hydrogens attached. So this is a condensed structure, and we'll use condensed structures quite a bit as we draw these molecules. The way that these molecules are named, they use the IUPAC system. That's an organization. It's called the International Union of Pure and Applied Chemistry. That is a system of nomenclature that organic chemists have agreed upon. A lot of these substances have common names. They've been around before the IUPAC system, but we all internationally need to agree upon. We're going to always call this molecule this one thing so that we can have a common language to talk about chemistry, organic chemistry, as we're studying it. So we use the IUPAC system. And the system is based on the following. You're going to have a prefix with each name. Okay, you're going to have the parent part of the name. And then you're going to have the suffix that comes after that. The ending of the name. And the way this works is the prefix names what we call substituents. So use that word over here. These are, I sometimes think of them as branches. They're like extra things that are on the molecule. The parent is going to tell us the number of carbons in the main part of the compound, what we're going to call the main chain of the compound. And then the suffix tells us the family that we're in. So, for example, we're going to be talking about alkanes. And alkanes have an ANE suffix, like methane, ethane, propane, butane. That ANE part is the suffix that tells us that we're in the alkanes and not the alkenes. So that'll tell us something about like if we've got double or single bonds or the type of compound that we have. Then we're going to use for the parent part, we'll use things like methyl, referring to, or meth, referring to, so like methane, ethane, propane. And then when we get into branches, we're going to use those same words, but we'll use them as like methyl, ethyl, propyl, butyl. So I'll list a couple of these over here. So methyl is a term for a single carbon branch. Ethyl, so we've got this YL part of that. Ethyl is a 2 carbon branch. Propyl is a 4 carbon branch, and there's butyl, etc. But usually those 3 are what we're going to start with. But we just take that the family name and put that YL ending there to get our branches. So we'll leave our branches over there. Let's talk about some of the steps of how we go about naming. Then we'll do like 3 examples. Okay. So the steps for naming alkanes, 1, we're going to find the parent hydrocarbon. That's going to be the longest continuous chain in our structure. We're going to number the atoms, 1, 2, 3, 4, 5, 6, etc. We're going to identify and number any branches or substituents that come off. Then we're going to write the name. Now, if we had a complex substituent, there's a last step naming that, but we're not going to look at that. So let's just look at a couple examples. I think that's the best way to proceed here. I've got 3 of them that I want to do. So the first one, I'm going to give you the structure. It's a condensed structure, but it has a branch coming off of it. So you might think, okay, well here, that looks like something's coming off that. And then it continues on over here, CH6. So there's a bond between that carbon and that carbon, okay? So the first thing that we need to do is we need to identify the longest continuous carbon chain. And it doesn't, we're only going to count the carbons, not the hydrogens here, but it doesn't have to be in a straight line. It can kind of zigzag around, but I need the longest chain of carbons. So I could go 1, 2, 3, 4, 5. I could go 1, 2, 3, 4, 5, 6, or I could go 1, 2, 3, 4. 6 was the longest, so I always like to box in my longest carbon chain, okay? It is 6 carbons long, okay? The next thing we want to do, we're going to keep that information in mind, that that's 1, 2, 3, 4, 5, 6 carbons, because that's going to tell us something about what we have, because 6 carbons, that's a hexane, because that refers to 6. And so it's going to be something hexane. So let's write that down. So because we know that that's 6 carbons long, it's going to be hexane, it's going to have some information out in front that's going to tell me about this. If it was only what I've boxed in green, that would just be hexane. But we've got a branch there. That's a substituent. So we need to deal with the branch. The first thing to do to deal with the branch is we want to number these carbons, and then we're going to kind of give them addresses. And the way it works is that we've got 2 ways we could number. We could call this number 1, 2, 3, 4, 5, 6. If we did that, this branch right here comes off of 1, 2, 3, the 4th carbon, if we number from this end. We always number from the end that gives us the branch off the lowest number of carbons. So, but if we go this way, we've got number 1, number 2, number 3, number 4, number 5, number 6. Notice that puts the carbon here, the branch, off the 3rd carbon. So we're going to number it that way, okay? Then we're going to name, we're going to look at the number of carbons in our branch. And our branch has 1 carbon. It's a methyl group, we say. So this is going to be something methyl hexane. And the thing we do is we put a little dash here and we put the number 3. We say that that's 3-methyl hexane because it's a hexane, 6 carbons long, that off the 1, 2, 3, 3rd carbon, there is a single carbon branch. So 3-methyl hexane is its name. Let's look at another example. Okay, so this has a couple branches off of it. We can deal with that. So let's first identify the longest run of carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Looks like 6 is our longest. Because of that, I'm going to pick the longest chain that has the branches on it. If I went 1, 2, 3, 4, 5, 6, I would create a complex branch, a branch that branched. I'm going to try to avoid that if I can. So I'm going to have a 6-carbon compound. So we know it's a hexane because the hex refers to 6, has all single bonds, so it's an A and E, so it's a hexane. Now we need to number those carbons. I could start here, go 1, 2, 3, 4, and 5 would be where my branches are. But if I start on this side, I go 1, 2, 3. So my branches are there. So I'm going to number these 1, 2, 3, 4, 5, 6. So I've got a branch off the second and third carbons. So I've got a 2 something, 3 something. Let's list what those are. This is a single carbon branch. It's a methyl group. It's off the second carbon, so it's a 2-methyl. I'm just going to write it up here to keep straight what I've got. This is a 2-carbon branch off the third carbon. If you're 2 carbons long, you're an ethyl group. It's off the third carbon, so it's a 3-ethyl. That number 3 tells me where it's located, its address. This has an address of 2, it's off the second carbon, 1 carbon long. This is off the third carbon, and it's a 2-carbon branch. Now, I just need to put those in front, but there's a rule. What am I going to put, the methyl group, then the ethyl, or what order do I write this? And the chemists have just said do it alphabetically. And so the International Union of Pure and Applied Chemistry has said we'll do it alphabetically, so E comes before M, so it's going to be 3-ethyl dash, they just use dashes to separate numbers and letters in these, 2-methyl hexane. 3-ethyl, 2-methyl hexane is the name for that compound. Let's do one more. These are all attached. I'm just kind of trying to space this out so you can see the branches. Okay, so I've got some branches on this. So first thing, it looks a little more complicated, but I bet this really, we just follow our steps and we'll be able to name it no problem. So I've got to go for the longest continuous chain. 1, 2, 3, 4, 5, 6 again. 1, 2, 3, but that doesn't include all that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 6 is actually, even if I curve that down and get the same name, so 6. So this is going to be something hexane. Again, kind of a theme here. It won't always be hexane, but my examples just happen to be. Now I need to number so that my branches end up, so here are my branches, let's circle those. I've got 3 branches here, and I want those to be on the smallest number. So looks like I'll start on this end, because that puts my branches at 2, 3, and 4. If I start here, I've got branches at 3, 4, and 5 carbons. So I'll go 1, 2, 3, 4, 5, and 6 for my numbers of where my carbons are. So I've got a couple branches here. I've got an ethyl, so let's list that one first, because first one that came to mind here. So it's off the third carbon, so that's a 3-ethyl. Okay, so it takes care of that. Then I've got 2 methyl groups, and the way that's named is like this. I'm going to say this. I'm going to say 2, 4 for their positions off the second and fourth carbon dash dimethyl. Dimethyl referring to the fact that there's 2 of the methyl groups, and their locations are off the second and fourth carbon. So those are our branches, 3 of them actually. And we're going to do that in alphabetical. So we're going to do the E first. So we're going to go 3-ethyl dash 2, 4 dash dimethyl. Running out of room there. Dimethyl hexane. 3-ethyl 2,4 dimethyl hexane. And that's a pretty substantial introduction to nomenclature of alkanes.